All right, let's get started with our interactive advanced concept presentation number 5. This week is copper coins and salt and vinegar, and we are going to have here's my hypothesis. If tarnished or dirty coins with copper content are placed in a solution of salt and acetic acid, then the buildup on the coins will dissolve and the coins will appear clean and shiny. So a couple of things. I have, I have 2 1-euro-cent pieces, 3 2-cent pieces. I have 1 10-cent and 1 20-cent piece. And specifically, you'll notice the difference in the color of the the first 2 rows and then the third row. First 2 rows are actually a copper, similar to our American coin structure for our pennies. They are copper outer layer with a steel core, and then the bottom 2 are actually called Nordic gold. No gold involved, but they are a brass alloy that are 89% copper, and there's also aluminum, zinc, and tin in that alloy. But with 89% copper, we're going to see if they react. And in addition to that, I have my white wine vinegar with 6% acetic acid, and I also have table salt. So without further ado, hey everybody, week 5 here for Chem 125. This is our interactive advanced concept presentation. This week is about reaction of copper and specifically the buildup on copper coins and how we can clean copper coins by creating a solution of vinegar. And here I have a bottle of German white wine vinegar, and on the back confirmed that it's 6% by biological fermentation. So we have 6% acetic acid in here, and I have my container of table salt, and I'm going to measure out into my non-metallic bowl here, roughly 1/4 cup, pretty small amount. I don't need much more than what it's going to take to cover the coins, so that's all I need there. Got my approximate teaspoon of salt heaping. We're looking to create a liquid. We're hoping to get all of the sodium chloride here to dissolve. I'll keep stirring this until we get a clear solution with all of the salts dissolved. I am in Germany right now, so I do not have access to pennies, but I do have euros. And specifically, I have euro cent coins. I have a 1 cent, I have a 2 cent, a 10 cent, and a 20 cent piece. And the 1 cent and 2 cent are actually copper. They're copper covering steel. They're a copper outer layer. And then the 10 cent and 20 cent are actually copper brass alloy. So they are an 89% copper with zinc and tin and a few other components that I will be able to talk about here in a second. All right, we are mostly dissolved in our salt here. The salt is mostly dissolved in our vinegar, rather. So, all right, that was an edit on the awkward transition. Now I've got a better view of the coins, and we'll get started. Okay. Better angle right now, so I just wanted to show you it up close and personal. We've got a 1 pretty tarnished, pretty dirty, 1 euro cent. Start with that, and pretty quickly we see how clean that becomes. In fact, here's one that was pretty clean to start with, and that's almost as clean just to start, just within the first few seconds. That 1 cent was probably my dirtiest example. I have 3 2-cent euro pieces, kind of in varying states, but not overly dirty or tarnished. A little bit of fingerprint smudge and a little bit of wear and tear. I'm going to add those in. And almost immediately, they all take to a really nice shine. And then lastly, we have fairly clean 10-cent euro piece and a 20-cent euro piece. And we'll drop those in. And unfortunately, they weren't terribly dirty or tarnished or had a ton of buildup to begin with, but they do appear much cleaner, and that was just after a few seconds of sitting in.
So, probably should have included a before picture here, but there was a significant amount of improvement overall in the amount of tarnish. So, I imagine with perhaps a longer soak time and even a bit of scrubbing to remove some of the debris that wasn't the copper oxide, but perhaps some of the oils from fingerprints and some of that other debris that wasn't affected by the acetic acid and the sodium chloride. Might see even more improvement. But without further ado, here is the specific reaction. You see that we've got 1 mole of copper 2 oxide, and that reacts with 2 moles of acetic acid, in addition to 2 moles of sodium chloride. And that gives us 1 mole of copper 2 acetate, 2 moles of hydrogen chloride, and 1 mole of sodium oxide. And there we have it. Pretty cool little experiment. And now I have clean coins.